So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is Count Caesar Cipher Pairs. So you are given an array of words of n strings. Each string has length m and contains only lowercase English letters. Now two strings s and t are similar if we can apply the following operation any number of times, possibly 0 times as well, so that s string and t string becomes equal. Now what is the operation? It says that choose either S or T, then replace every letter in the chosen string with the next letter in the alphabet cyclically. So if A is the character, then you can replace it with B. B is the character, you can replace it with C because this is the next character, and also cyclically. So if Z is the character, its next character will be A because it is a cycle, so it will again start from A. So this is what the question is saying, and in the end you need to count the number of pairs of indices I and j such that j is greater than I and words of I and j are similar. So words of I and words of j are similar. In the end, just return the integer denoting number of such pairs. So let us understand with the help of second example what the question is saying and how we can find solution out of it. So the second example has the words AA, AB, AA, ZA and AA. So let me just write down here so that we can understand in better way. AB, AA, ZA, and I think it was again AA if I am not wrong. So AB, AA, ZA, AA. Yes. So this is the words array that we have been given. Now what we need to do, let's say if this is the first word AB. Now what operation we can do? We can convert, we can just make each and every character to its next character. So this string can become BC. Now we can do this operation any number of times. So we can do this again. This will become CD. Again if we perform this operation, it will become DE. So on and so forth we can do the operations, and we need to find such pairs if the two strings S and T can become equal after performing these operations any number of time. Again, it is not permitted that we need to perform this operation one number of time only. So in this case the answer is 2. Why? Because the two pairs are obviously this AA and AA because they are already similar, because we don't need to perform any operations. The other pair is AB and ZA. ZA. Now in this ZA we can perform one operation and it can become AB. So AB is equal to AB. So we found two such pairs. So that's why we return output as 2. Now how will we solve this particular question? Now if you observe one thing carefully, if we are given string AB, what we are doing? We are performing operation on each and every character to make its the current character equal to its next character. So it will become BC. Similarly, next it will become CD, and so on and so forth. So if you observe one thing, we are restricted to convert each and every character to its next character. It is not that A can be converted to B, B can remain as it is, or B can be converted to D. If we are performing operation one number of time, we need to apply it to each and every character. So what can we derive from this particular idea or this particular observation? We can say that we can perform at most 26 operations on this particular string, at most, because if we apply more than 26 operations, it will become this particular string AB again. So it is AB. Now let us take the other example. Instead of AB we can say, okay, if we take AA, this is easier to understand. So its next operation, after doing one operation, it will become BB, then CC, so on and so forth. It will become till ZZ. Now after we perform operation on ZZ, it will again become AA. So this become to the like initial word only. So we can at most perform 26 operations because there are 26 alphabets in our English language. So if there are 26 alphabets, if we want to just move it to the next character, and after this we can apply this particular operations any number of times. So how many times we can perform this operation? If obviously 26 number of time, because if we are at A, it will become B, then it will become C, after some time it will go to Z, and it will again become A. So this can at most we can apply 26 operations. And if we can apply 26 operations, can't we calculate or can't we get all of the transformation, all of the 26 transformation? So we can get all of the 26 transformations for AB, we can get all of the 26 transformations for this AA, similarly for ZA again, and again for AA. Now if we have all the 26 transformation, can't we actually count the total number of pairs that will become equal? Yes, we can do that. How we can do that? Let me just show you. So what we can do, we can create an unordered map and store each of the words frequency inside that unordered map. Why unordered map? Because here we don't need to do anything with the ordering of the elements or ordering of the words. We just need to find whether this word exists or not, and if it exists, how much is the frequency. So we can create an unordered map and just keep storing all of the words frequency. So AB is present one number of time, AA is present two number of time, and ZA is present one number of time. Now what we can do, we can pick each and every word and we can find all of its 26 transformations. So first we have AB. So we can find all of its transformation. One would be the AB itself, then it will be BC, then it would be CD, so on and so forth. The last will be ZA. Now we can see how many of these transformations are actually existing with us in our words map, or simply this unordered map. And those number of words, we can group them together because they can be similar. That is what we want to find. So this is one word, AB is present one number of times. So AB is one word which is there. The another word is ZA. So ZA is present one number of times. So these are the two words. Now from these two words are similar. So how many pairs can be possible with these two words? Obviously only one pair is possible. But instead of two words, here in this case we got two words. What if we have some, let's say, X number of words? So let's say these are the pairs that we got from AB, not AB, let's say some other example. So if we have X number of words present, then that can be similar. So how many pairs that we can form? Now pair is formed by selecting two elements. If we have X elements, we need to select 2. So how many ways can we have to select two words from X number of words? Obviously X C2. So this is nothing but X into X minus 1 by 2. So this is how we'll count the pairs. So in this case we have two words. So two words are AB and ZA. So there are total two words. So X value is 2. So how many pairs can be possible? 2 into 2 minus 1, that is 1 by 2. So 2 can cancel and the answer we got is 1. So with this word we have found one pair that can be made similar, or that are similar. Now we will move on to this next word, AA. Now for AA we will also calculate each and every transformation. So AA is there. So first transformation will be AA itself, then it will be BB, then it will be CC, and so on and so forth. The last will be ZZ. Now we will check, okay, how much is the frequency of this AA? So AA is present two number of times. So we can say AA comma AA. Now is there any other word that is present in our unordered map? No, there is no other word. So we found two words that are same actually, AA and AA. So how many pairs can be possible? 2 cross 1 by 2. So again 1. So total number of pairs are what? These AB ZA and this 2 times AA. So the previous was 1 and currently we have 1 pair. So total pairs that we have is 2. Now you say, why didn't you check this ZA? So we have already actually checked ZA when we were computing all of the transformations for AB. So in that transformation, if you remember, the last transformation was of ZA only. So if we have AB, so its transformation was BC, CD, and up till the last was ZA. So we have already calculated ZA in this AB part only. So why will we compute it again? We will count it one more number of times. So we don't want that. The answer will be wrong in that case. But how will we make sure that we don't count this again? So what we can do, we can simply create another unordered map and count all of the transformations frequency. So we can create another unordered map. Let's say we are calculating the transformations for this AB. So first will be AB itself, second will be BC, then it will be CD, so on and so forth up till ZA. So we can create the frequency map in which we will be storing all the transformations frequency. Let's say AB is 1, BC is also 1, CD is 1, and similarly ZA is 1. Now after getting the total number of pairs with this AB and this AA, we will come to ZA. Now we will check whether we have already computed, whether in the previous case have we somehow already calculated directly or indirectly for this particular word or not. So we will check in the transformation map whether this ZA exists or not. So yes, ZA exists. That means in previous words we have already calculated or included this particular words as our answer. So we won't calculate this again. Similarly for AA, we will check again. So we will have the when we are computing the AA's transformation, so we will have also AA frequency 1, BB frequency 1, so on and so forth. So we will say okay, AA is already present inside a transformation map, so we will not count this again. So this is how we'll be solving this particular problem. Just calculate all the 26 transformation, check whether how many number of times a particular word is present, count total number of words, how many pairs we can form, and just add those number of pairs to your answer. Then do the same for the next word and then next word, and so on and so forth. So I hope you understand this solution. So let us directly see the code now. The code is pretty much easy only. So yes, this is the code. So I have initialized one unordered map initially, that is MP, which is storing string and its corresponding frequency. Then N is the words size, words vector array, so its size. Also I am keeping another unordered map, which is transformation, which will be storing all the transformations that we have, so that we don't count a particular word again, or we don't calculate all the number of pairs that can be formed with a particular word again. So first what we are doing, we are just like updating the frequency of all the words inside our MP map. Then long total is the final answer, the similar pairs that we can get, that we will be returning in the end. So total is that initialized to 0. Now what we will do, we will first compute all of the transformations, all the 26 transformations for current word. So we are iterating on the words array. For each and every word we are calculating all the 26 transformations. But before that we are checking whether we have already done the operation in somehow directly or indirectly previously or not. So we will just check whether this transformation is, or this particular word is present in a transformation map or not. If it is present, we don't need to calculate again, just continue. If it is not present, okay, just compute all of the transformation and find the similar pairs that we can get. So we have initialized answer to 0. This answer is nothing but the x that I was talking about, x number of words that can be grouped together. So this answer is that x only. Then we are computing all of the transformations. So this is the first word. The first word we will also consider the word itself as the transformation, because if we don't do any operation on the current word, that is also considered as the transformation. So I am keeping a string transformed, which will get the new transformation that we can get. So then we are just computing all the transformations. So we are just going on to each and every character and just going into the j number of steps. So here you can see first we have 0 number of steps. So let's say A is the character. So after applying 0 steps, A will remain as it is. Now if let's say j was 1, so this A will be transformed to B. So this is what here we are doing, and we are modding it by 26 because we need to do in cyclic order, so that Z's next character we get as A. So simply we are just whatever the next step is, we are adding to the A character and we are just replacing it with the current index in the transformed string. In the end we are just keeping the track of this transformed string that we got into our transformations map, so that we can make sure of this particular condition. In the end what we are doing, whatever the frequency is, we are just adding it to our answer. This answer is nothing but the x, the number of words that can be grouped together. In the end, how many pairs that we can make from this answers group or this x group? Nothing but x into x minus 1 by 2. In this case it will be answer into answer minus 1 by 2. So this is how we are doing, answer into answer minus 1 by 2. Simply multiplying it with 1 LL, so that because we have long here, so we want the this particular computation to return in long only. So that's why we are multiplying it by 1 LL. So we are just adding the total number of pairs into our total variable. In the end, after doing this for each and every word, we are just returning the total number of similar pairs that we can get. So I hope you understand this solution. So thank you for watching.